Okay, so on this question, let's read it first off. A person standing close to the edge of on top of a 108-foot building throws a ball vertically upward. The quadratic function right there models the ball's height above the ground, h of t, height, in feet, t seconds after it was thrown. This is a little physics formula in other words. They're asking us, what is the maximum height of the ball? How many seconds does it take until the ball hits the ground? Okay, so we're talking about a little physics formula here. Let me give you the idea. We don't have to graph this one, it's not required, but I think just a general idea of the graph would help us. I'm not going to get specific at all, but I'm just going to say, hey, let me just draw a little XY axis. First off, X and Y, okay? And what does this function look like? Well, you guys know we've been doing a bunch of these. T squared or X squared, same thing, whatever. That's always U-shape, isn't it? All the times we graph an X squared or a T squared, it's either a U-shape up or it's a U-shape down, right? These are all, we call them parabolas. They're U-shapes, quadratics, whatever you want to call them. They're a U-shape up or down. Now, how do you know whether the U-shape is going to go up or the U-shape going to go down? Well, it's what's right in the front, right? That there's a negative in the front of the T squared. So that means it's going to go, the U-shape is going to go down. At the very front, most powerful term is positive, the U-shape goes up. If it's negative, the U-shape goes down. So this is going to be a negative U-shape. Now, beyond that, I won't worry about any more details, but basically, the graph is going to do something like this. It's going to go something like that. Good enough. It's a U-shape going down. That's about all I care about. No, why? Why do we care about that? Because what does that look like? That looks like somebody throwing a ball, doesn't it? Does that make sense? That's exactly what it is, right? If you were to throw something, it goes up and then down, right? Baseball, golf ball, whatever. So if you throw something, it's going to go up and then down. So that's what's going on. So we don't, this last part I just drew, we actually can skip that. Start right here. And this will be the little person right here. Well, I should say the person's starting at a height. Well, anyway, I won't bore you with details. Enough said. Somebody's throwing the ball. Let's just track it out. Now, instead of X, we actually have T. How do I know? Well, see, it's T. And the Y is H of T. So this is H, height. In other words, the Y-axis is the height. The X-axis is time. It's how high the ball is at different times. Is that making sense? So here's the ball. It's going higher, 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 higher. Right here, it's at the maximum height, which they're asking us about in this first question. Right there. In fact, let me just do that right there. Here is the maximum height of the ball. And then it starts coming down, 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 boom. And right here, it hits the ground. Really, it can't go below ground, can it? Remember, math isn't real. So sometimes it goes beyond reality. So we'll just stop right here. The ball hits the ground. Those are the 2 points we need to find in this question. Part A, they're saying, what's the maximum? We got to find that point where the ball is at its highest point. Part B, how many seconds till it hits the ground? Notice right here, what is the time when it hits the ground? So it's basically an upside down U-shape, and we need to find the peak, the maximum, and we need to find when it hits the ground. What's that called? X-intercept. So how do we find? Let's do the first one, part A. Find the maximum. So that point, if you notice, is the center of the U-shape, isn't it? That maximum is the very center, right, of this U-shape that goes down on both sides. That maximum is the center. Well, we already have a formula for how you find the center. Bring it down here, part A. So how we find the center, the max equals the center of the graph, also called the vertex. Call it whatever you want. Anybody remember the formula? It's X equals negative B over 2A. Remember that? That's how we did that in an earlier section, right? That's how you find the center of the U-shape, the middle of the parabola. x equals negative b over 2a. So that's going to be, okay, now what do we mean by b and a? Well, we mean this right here. This is a, this is b, and this is c, right? A, b, and c are the numbers in front of t squared, t, and no t. So here we go. It's going to be negative, and I'm going to plug in b over 2, and I'm going to plug in a. So what are they? Well, it tells me the b is 132. The a is negative 16. So I just grabbed the a right here and the b right here, plug them in. So that's what, minus 132. Use your calculator. This would be minus 32. Divide those on your calculator. Somebody have the calculated number there for me? What is minus 132 divided by 32? We got that?
4.112.
Oh, 4.125. Good. So that's 4.12, and it's positive because two negatives make positive. Thank you. Perfect. 4.125. Now, careful. That's just the x value. In other words, and x is really what? X is t. Notice the x-axis is actually time. Why? Well, because that's the letter they gave you. They gave us t in the formula instead of x. Huh? See that word? I'm just right here. It's here. It's here. It's t. So t is x. You know, call it whatever you want. Normally, we call the sideways axis x. They're calling it t. They have t in the place of x. I hope that isn't confusing you. Does that make sense? They have t. So this, when I find x, I'm really finding this is really t. Anyway, who cares? Whatever. So what I really want then is I want the height. What's the height? Well, how am I going to find it? I got to find the y then. Remember how we then go on and we find the y? So now I'm going to bring, this is, or I'll just call it h. It's the formula is h, grabbing the equation. There's minus 16 t squared plus 132 t plus 108. And so then I'm going to grab that 4.125 and I'm going to plug that in there, t, and there, t, because that's actually t. That's actually seconds. Is what that is. That's actually t equals 4.125. So that means the ball is at its maximum height 4.125 seconds after it's thrown. But I don't want that. I want to find that height now. So you got to plug in that t back to the formula to find out what that is. That's going to be h height equals minus 16. Plug in that 4.125 squared plus 132 times 4.125 plus 108. All right, hit the buttons.
Yeah.
And hit the buttons on your calculator and find out this. I'm going to hit the buttons. Let's see what I can get. And I'm getting 308.25. So that means the height, the maximum height of that ball is 308.25. That means right here at the max, this is the point. It's at it's over at 4.125 seconds, and it's up at a height of 308. So this is the point over 4.125 up 308.25. So that means at 4.125 seconds, the ball is at its highest point, 308.25 feet. That's how they do it with physics. That's a physics formula. So I'm plugging in there. But plug in that x value, or the t value, same thing. So I found, so again, how did I find that? I used the formula we've been using for a while now to find the maximum or the center of a U shape, which is x is negative b over 2a. Got the b, got the a, plug them in, got the x or t, same thing, x and t are the same thing, right? The x-axis is the t-axis because they used t instead of x, same thing. Got that answer, and then plug that into the original formula to find the height, the h, what the h would equal. And hit the buttons on my calculator, 308.25 feet. Now, the second part of the question, part B, from part B, they want us to find how many seconds does it take until the ball hits the ground. Well, it hits the ground right here, as we can see. What do we know about the moment the ball hits the ground? How high is the ball right when it hits the ground? Well, 0. It's on the ground. Exactly. So I take the formula. Take this h formula they gave me, which we're writing in minus 16 t squared plus 132t plus 108, and then I realized when the ball hits the ground, h equals 0. Huh? Its height is 0. At the moment the ball hits the ground, its height is 0. So that means I just take this little formula, I plug in a 0 there. I go 0 equals minus 16t squared plus 132t plus 1, right? They're saying find the time, find t, when the height is 0. So I plug in 0 for the height, and now I have to solve that equation for t. How do you solve this equation? This minus 0 equals minus 16t squared plus 132t plus 1. How do I solve that? Well, that's what we just did in the last section. So we solved x squared or t squared, whatever, same thing, equations, huh? We learned how to solve x squared equations, didn't we? So that we could now do it in this real physics situation. By the way, this is an accurate formula. This is the real physics formula for how you would determine the free flight of any object through the air that doesn't have its own engine. You know, anything free falling, really, under the influence of gravity alone. This is the right physics equation. And so here's a real life practical use of what we learned last time, how to solve x squared equations. We need it now. So how do you solve x squared equations? You go grab the quadratic formula. So what's the quadratic formula? Let's write it out here. So it's going to be square root here. Remember the quadratic formula? Negative b plus or minus the square root b squared minus 4ac all over 2a. Plug into that thing. So negative b plus or minus the square root of b squared minus 4a and c over 2 times a. So I'm going to plug in the numbers now, right? You know what we're talking about. A is right here, minus 16. B is right here, the 132, and C is right here, the 108. So let's plug these in. Negative b, negative 132, plus or minus square root of b squared, 132 squared, minus 4 times minus 16, which is a, times c, which is 108 all over 2a, 2 times minus 16. So just like we learned to do, use the quadratic formula, you plug in your a, b, and c. And then you, as my old physics teacher used to say, you just turn the crank. Now you just turn the crank out the numbers. Here we go. So what do we got? Negative b, so negative 132 plus or minus. So 132 squared. So let's crank out these numbers. So yeah, so 132 squared. I'm getting 1742. These are very big numbers, aren't they? And then over here, notice, careful the signs, right? The main thing is sign. See, negative times positive. So what's happening there? Two negatives, right? So it's going to be positive, and then just multiply the numbers on your calculator. 4 times 16 times 108. So positive 6912 on the bottom, 2 times minus 16 minus 32. All right, so keep going. This is going to equal minus 132 plus or minus. Let me see, 1, 7, 4, 2, 4 plus 6, 6, 9, 12. I'm getting in here 2, 4, 3, 3, 6 over minus 32. All right. So what does that mean? That means there's two options here, aren't there? So there's minus 132 plus the square root of 24336 all over minus 32. Or what's the other option? Minus 132 minus the square root of 24336 over minus 32, right? So we have the plus and the minus option. Plus and then minus. Have those two different options. So we have to calculate both of them and see which one's really the answer. So the first one is going to be oh, and I did the square root. Yeah, so yeah. Maybe I won't bother you with that. The first one, I'm getting negative 0.75. And then the other one, is coming out 9. All right, now, how do we know which answer is right? How do we know which answer is actually correct? Well, remember, what are they? What did we just solve for? T. Remember, we just solved the t squared equation. We just solved the t squared equation. So these are both time, aren't they? This is t. So when we say, what is it? We're saying t equals or t equals. This one right here is back in time, isn't it? It's negative time. Why is math giving us that crazy answer? Well, because all math did was look at our little picture and go, oh, well, back here, it would have hit 0. Well, that's back in time. That's tracing the ball backwards in time, which we can't really do. Again, math doesn't know about reality. Math is made up. So sometimes it goes beyond reality. You just throw that away. The real answer is the positive one. There it is, 9 seconds. After 9 seconds, the ball's going to hit the ground. That's what we just did. So let's recap this question. What did we just do? They gave us this minus t squared graph, which is an upside down U-shape. Right? X squared graphs are U-shapes. A minus x squared graph is an upside down U-shape. And so that's the ball traveling through the air. Then they asked us for the maximum. How do you find the maximum? That's the center or the vertex of a U-shape. Formula for that is x is negative 2a. Found that, then plug that back into the H formula, found the height, 308.25 feet. Then they asked us for when the ball hits the ground. When the ball hits the ground, the height is 0. So you take the original formula, you plug in 0. For the height, solve the x squared equation, which requires the quadratic formula, plug everything in, get your two answers, throw away the negative answer. So the real answer, 9 seconds later, the ball hits the ground. That's how physics does it. That's how they track artillery, the military does. That's how you can track the flight of a baseball, a golf ball, anything that doesn't have its own engine. That's exactly the physics formula. There we go.